All right, guys, I'm going to hand back your quizzes in a minute so you can have your law of sines, law of cosines quiz. But your test on Monday, guys, listen, your test on Monday is going to have two cosine, law of sines, or area. I'll give you all the formulas again, but only two. The rest of the test, the rest of the 9 questions will be, the rest of the test will be all from 6364. So the two law of sines, law of cosines, or if it's an area, it'll tell you, use the law of whatever, just draw the triangle, figure the stuff out. The majority of your test is going to come from 6.3 and 6.4. This is the answer key to the review. Some of you worked it out, some of you didn't. No big deal. I told you you didn't have to. I will post this so you guys have it. But some little things I want to remind you of. If they give you 2 points and it says find the component form of a vector, remember it has to be terminal. What does terminal mean? The end, terminal minus the initial. It has to go in that order. If it doesn't, then your signs are going to be wrong, which makes a big deal. It's terminal minus initial. Then you get your vector here. Remember, first with first, second with second. Always keep first stuff with first, second with second. When you write your component form of a vector, make sure you have your pointy things on the end, however you want to say it. All right, super important. Then it's going to ask you to find the magnitude. Well, the magnitude is where you just take the vector that you found, and you take each piece of it, square it, add it together, take the square root. If the square root breaks down, like if you had the square root of 32, is that the most exact answer? Can you break down 32? Yes. What can you break down 32 in? 16 and 2? So this would become 4 root 2. Anytime you have a radical, you have to try and break it down. Make sure you guys do that. Any questions? All right, then there's going to be, a variety of questions where I give you 2 or 3 vectors, and I just say, here, add them together. Multiply, then subtract. Find the dot product, that sort of a thing. You guys are going to have to understand what to do. That is not when you come up and say, are you asking me to? No. You guys have to know what to do. When you have numbers in front, what does that mean to do? Distribute, all right? If you have a bold, and it will be on the test, dot in the middle, that does not mean multiply. If I want you to multiply something, there will be parentheses or numbers stuck in front, but this is dot product. How do you find the dot product? First times first plus second times second, all right? Okay, if I ask you, this is like number 8 and 14 from WebAssign. From your, what was it, 6.4 WebAssign? I did a video on this yesterday. I worked both examples out in class, and I also worked them out on a video and posted it. You're going to have to be able to find what makes vectors parallel, what makes them orthogonal. When we talk about parallel, it's the first over the first. Does that equal the second piece over the second piece? If they are equal, they're parallel. If it asks you to find, then you cross multiply and solve. Remember what makes vectors orthogonal? If the dot product is what? Is 0. Good. You guys need to be able to do that. How do you show if vectors are equivalent? Vectors are equivalent if what? If they equal each other. So the magnitude and direction have to be the same. They are equivalent if the magnitude and the direction are the same. What is another word for magnitude? Distance or length, right? And what's another word for direction? Slope, good. So if you're given 2 vectors and it says, are these 2 equivalent? Show me how. Prove. You have to do the distance formula. You got to find how long it is, and you have to find the slope. Make sure the direction is the same. Does that make sense? You guys have any questions on that first page? You okay, Andrea? Yeah. All right, second thing, guys. The angle between 2 vectors. Here's your formula. You guys are not going to get this one, but this isn't that hard. Cosine theta equals, what is this UV? Dot product, good. The dot product's on top. And then what's on the bottom? Magnitudes. And again, the hardest thing for you guys is not going to be the figuring out what goes where. It's putting it in the calculator. Parentheses are your best friend. You have to make sure that when you get this answer here, when you get the cosine of theta equals some teeny tiny little decimal, is that your answer? Yes or no? No. In your calculator, you need to hit what? Cosine -1. And then you'll be able to find your angle measure. But if for this case, guys, you should not get an error in your calculator, and you should not get a negative angle measure. So if you do, just go back. You did something wrong. You got to recheck it. There will be one of these. I did this yesterday on an example on WebAssign. It's on a video. You'll be given the unit circle. So when they give you the angle here, like 2 pi over 3, why is that important? What else are they really giving you when they give you that? They're telling you what the angle is, but when you find the ordered pair, they're giving you the cosine value. So you just literally set it up. You can do it the way I did it. I solved first for the dot product and then just plugged everything in. You don't have to do it that way. You can do it like we did yesterday, where you set it up as a proportion. You could say cosine, so it's 1/2, right, equals the dot product, which we don't know, we're trying to find, over the magnitudes, which would be 8 times 15. So you have 1/2 equals the dot product, which we don't know, over, what's 8 times 15? 120? And then cross multiply, all that good stuff. This should be negative. And then solve. Either way you want to set it up, doesn't matter. You see how this one is just, I solved first for the dot product and threw everything in, that's fine. Questions? No? Right. Last thing, you need to be able to prove if vectors are orthogonal, parallel, or neither. So if you're given two vectors, to prove that they're parallel, again, you put first over first, second over second. So in this first case, look, are those two things exactly the same? No, so they're not parallel. So if we think it's orthogonal, we say, okay, is the dot product 0? First times first plus second times second. In this case, guys, look, be careful. These numbers are very similar. The only thing that's different are signs. Very easy to make a mistake, miss a minus sign, and you say, oh, 30 minus 30 is 0. So just be careful. Number 12, again, first over first, second over second. When you reduce it, you see, oh, they are the same. Perfect. And then in the last one, again, I checked to see if they're parallel. They weren't. So then for orthogonal, first times first plus second times second, my dot product was 0. That's why it's orthogonal. But it's pretty straightforward. You're allowed to use your calculator. I am going to say, though, no decimal answers. So either keep things as fractions or as square roots. No decimal equivalents. I'm even going to have you round to the nearest whole number on the law of sines, law of cosine stuff. So it's just easier. But very straightforward. Nothing too crazy, I promise. You guys have any questions? No? All right, then we're going to chapter 9 next week after our tests.